Welcome back to Arxflix. Today, we're diving into an exciting new paper titled MindEye2. Shared Subject Models Enable fMRI to Image with 1 hour of data. This research addresses the challenge of efficiently reconstructing visual perception from brain activity using minimal fMRI training data. Let's get started. Reconstructing visual perception from fMRI brain activity has advanced significantly. However, practical use has been limited because traditional methods require dozens of hours of fMRI data per subject. MindEye2 changes the game, showcasing high-quality reconstructions with just 1 hour of fMRI training data per subject. Here's an overview of the MindEye2 pipeline. The model is pre-trained on data from 7 subjects and then fine-tuned with minimal data from a new subject. This figure depicts exactly how the brain data undergoes transformation through the model to the final image reconstruction. MindEye2 uses a shared subject functional alignment procedure. This method linearly maps brain data from multiple subjects into a shared latent space. A shared nonlinear mapping is then applied to the clip image space. Finally, the model fine-tuned Stable Diffusion XL to accept these clip latents instead of text inputs. By leveraging pre-training on multiple subjects, MindEye2 attains state-of-the-art results in image retrieval and reconstruction, comparable to models trained with 40 times more data. Every brain is unique, so aligning brain data across subjects can be tricky. MindEye2 uses ridge regression for this functional alignment. The process maps fMRI activity to a shared latent space, accommodating the unique neural patterns from each subject's brain. The overall loss function combines the diffusion prior, retrieval submodule, and low-level submodule losses. Flattened patterns of brain activity are mapped to a shared subject space before being processed through a multilayer perceptron (MLP) backbone. These embeddings are then passed through a diffusion prior and submodules for reconstruction and retrieval. The diffusion prior aligns the outputs from the brain activity with clip image embeddings. The retrieval submodule ensures the brain embeddings can find their corresponding images, and the low-level submodule retains fine details in the images. Here's a side-by-side comparison showing reconstructions refined by the base Stable Diffusion XL model. MindEye2 was tested using the Natural Scenes dataset, a rich fMRI dataset of human brain responses to thousands of images. The results are quite impressive. MindEye2 achieved state-of-the-art performance across image reconstruction and retrieval metrics. When compared to other models, MindEye2 excels in both low-level and high-level image metrics, even when using just 1 hour of training data. This figure shows side-by-side comparisons of reconstructions using 1 hour of training data from different model approaches. The practical applications of MindEye2 extend beyond mere image reconstruction. By drastically reducing the amount of fMRI data needed, clinical diagnostics, brain-computer interfaces, and more areas stand to benefit. There are, of course, limitations. fMRI's sensitivity to movement and its applicability limited to natural scenes are areas for further exploration. Nonetheless, MindEye2 paves the way for significant advancements in neuroimaging and AI. That's all for today's overview of MindEye2. Don't forget to check out the code on GitHub and read the full paper for a deeper dive into this groundbreaking work. Thanks for watching, and see you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.